Hi, Stephen Talcott-Smith, founder and CEO of Allogica here. Today I want to talk about how to allocate software development tasks within the Allogica system for maximum efficiency. Efficiency is basically how much output in terms of work product we can get out of a given team and time commitment. It is the ratio of actual performance against some theoretical ideal. The team and time allocation is our capacity. What we are trying to do is allocate work in such a way that we maximize the utilization of our capacity and bring our actual performance close to our ideal performance. Software development is a team sport. Some of us work alone, but the vast majority of professional developers work in a team. In teams, people have different capabilities and skill levels. No two developers are exactly the same. That said, in full-stack application development, each individual in principle should be able to contribute in any part of the system. If we have a backlog of features to build, in theory, any developer on the team ought to be able to tackle any of the features. In principle, in theory, these are wiggle words. A lot of developers like to specialize. But specialization can be bad for utilization. Here's why. Let's say you have two developers, Dan and Kia. If you divide your system into architectural parts, Part A and Part B, Dan works in Part A and Kia works in Part B. Let's say the backlog for the next 6-week cycle leans heavier on Part B. 22 points in Part B and 14 points in Part A. Naturally, Kia takes Part B because that's her area. Heading into the last 2 weeks of the cycle, Kia and Dan have each delivered 14 points. Dan has some time, but he is going to be slow to develop in Part B, perhaps very slow. Skill level aside, if each developer were equally capable to develop in either part, Dan could very efficiently pitch in to deliver the Part B items. This is one reason why full-stack developers are more valuable. They are more flexible. One person can stand in for another more easily. But let's assume both developers are full-stack capable so they can contribute to any part of the system. Likely, they have different abilities. Perhaps Dan has only 5 years of programming experience where Kia has 12. We'll use years of experience as a proxy for capability. We know those are not exactly the same and sometimes have little relationship. There are different kinds of tasks or stories in the backlog. Some will take Kia and Dan about the same amount of time, regardless of their differing skill levels. We'll call those isochronic tasks. For other tasks, Kia might be faster due to her greater experience. And for some tasks, Dan might be faster due to greater familiarity with some technology or part of the system. We'll call those heterochronic tasks. In some cases, tasks that are bounded for Kia may be unbounded for Dan. Generally, we want the tasks to go to the person who will be fastest at executing them, and we want to minimize unbounded tasks, which present schedule risks. So heterochronic tasks generally will go to the fastest developer with strongest preference given to the tasks which are most unequal in their expected time to complete. Every isochronic task that Dan takes frees Kia up to take heterochronic tasks for which she will be faster. This makes a strong contribution to the overall efficiency of the team. It is important to recognize this because Dan may feel that he is not doing as much because of the big difference in ability, which he surely recognizes. Junior team members can play a very important role in helping more capable team members maximize their efficiency. That is why all teams ideally should contain a mix of skill levels. In theory, a team of all expert developers may be faster overall than a team with a mix of skill levels. However, the additional cost may not be worth it if the workload has a significant number of isochronic tasks. Let's recap this in terms of how to allocate work to each developer to maximize utilization. The less capable developer should give priority selection to those few tasks for which they might be faster, followed by those for which they are about the same or not much slower, followed last by those for which they will be much slower. The less capable developer should avoid as much as possible any tasks which for them seem unbounded. The most capable developer on the team should first take on those features or tasks which may appear unbounded to the less capable developers, then should select tasks which are heterochronic, which they will complete more quickly, followed by tasks which are isochronic. There are some cases where we want the less capable person to take on a task for which they will be slower. We do this as an investment, say in bringing them up to speed so they can be almost as fast in another part of the system with which they are less familiar. It's an investment in expected future productivity. If you are a professional software developer and you really want to go in depth to learn the tools and techniques of the Allogica system to multiply your value and become a 10x developer, register for my free intro course at 10xdevacademy.com. That is 10xdevacademy.com. And look for my other videos on this channel or site. Thanks for watching.